Alright, number 2, we're given the population of Snorlax in thousands, T years after 2000, is given by this equation. Hopefully you recognize this as one of those logistic curves. Part A asks us to find and interpret y when t equals 0. So when t equals 0, we're going to substitute. We get 2.5 over 1 plus 3e to the negative 0.1 times 0. So that's 2.5 divided by 1 plus, well, e to the 0 is 1. So I get 2.5 divided by 4. So 2.5 divided by 2 is 1.25. You divide that by 2, you get 0.625. So that's the find part of the problem. What about the interpret part? Well, t equals 0. T represents the number of years after 2000. So t equals 0 corresponds to the year 2000. So in the year 2000, what? The y value is 0.625. The y measures the population of Snorlax in thousands. So in the year 2000, there are 0.625 thousand Snorlax, or in other words, there are 625 Snorlax. Part B. What is the limiting population of Snorlax? Well, there's two different ways to go about this. You can either memorize a fact about the logistic function or you can go through the calculus. When we talk about limiting population, we're talking about what happens as t goes to infinity. So let's talk about what happens as t goes to infinity. As t becomes a large, big positive number, like a billion or a trillion, look at the exponent. If I take a billion or a trillion times negative 0.1, I still get a very large negative number. E to a very large negative number is a very small positive number. 3 times a very small positive number is a very small positive number. So this term is going to 0, which means the y is going to 2.5 over 1, which is 2.5. Alternatively, you can choose to memorize if the logistic function is given in the form L over 1 plus a e to the negative klt. You can memorize that the L there is a limiting population. But 2.5, we have to once again interpret what that means in this situation. 2.5 is a limiting y value, and once again y measures the Snorlax population in thousands. So we would say that the limiting population of Snorlax is 2.5 thousand or 2,500. Sometimes this is also called the carrying capacity of the environment. The environment won't support any more than 2,500 Snorlax. Okay, part C. We're asked to write a differential equation which corresponds to this model. So the general logistic equation as presented in class, dy dt, is k times y times L minus y. And the general solution as presented in class is L over 1 plus a e to the minus klt. And so what we need to do is figure out the k and the L based on our solution. Well, we're given 2.5 over 1 plus 3 e to the minus 0.1 t. So we can pick off the L as 2.5. We saw that before. And the k times L has to be the 0.1. So substituting in my value for L, 2.5k is 0.1. So k is 0.1 over 2.5. If I convert this to a decimal, or excuse me, a fraction, I'm taking 1/10 divided by 5 halves. That's 1/10 times 2/5, which is 1/25. Since I've got my k in terms of a fraction, I might as well convert L into a fraction as well. And so I get my differential equation dy dt is 1 over 25y times 5 halves minus y. And so that's the logistic equation for this. Okay, so part D asks us to use our answers to A and C to find y prime when t equals 0. So here's the logistic equation that governs this model. Dy dt is 1/25 y times 5 halves minus y. And we know that y at 0 is 0.0625, which, since we've got fractions here, that's 5/8. So the point is that this logistic equation gives us the derivative at any time t in terms of the population at any time t. So if I want the derivative at t equals 0, I just need to plug in what the y value is when t equals 0, which I already know. So y prime at 0 is 1/25 y at 0, which is 5/8, times 5 halves minus 5/8. So that's 1/25 times 5/8 times, this would be 20/8 minus 5/8 is 15/8. And so there's a good amount of canceling we can do here. And I get 3 over 64. So that's finding y prime when t equals 0. What's the interpretation? Well, y represents the population of Snorlax and t represents time. So this is a population rate of change. It's a rate of change of population. So when t equals 0, it's the year 2000. So we can say in the year 2000, the population of Snorlax is what? Well, since this is a positive number, it means that the population is increasing at a rate of 3 represents 3,000 Snorlax per 64 years. Now if you have a calculator handy, you can take 3,000 divided by 64 and you get something like 46, 47 Snorlax per year. And that'll do it for checkpoint quiz 4.